Okay, so today we are going to talk about what? Inverses of matrices and matrix equations. So, um, to find the inverse of a matrix, what we're going to deal with today is an identity matrix. So the first thing we can look at is the multiplicative identity as an example. So one is called the multiplicative identity because if you multiply any number by 1, you're going to get that same number back. So for this it just said A, but if you had 3, 1 times 3 is the same thing as 3 times 1, and that's going to equal 3 for all numbers A. Now that's going to happen no matter what number you choose. 1 times 2 is 2 times 1, and that's still going to be 2. For the matrices, though, we're going to have an identity matrix. It's a square matrix, which means it has the same number of rows as columns. And the main diagonal of the square matrix is going to actually be all 1s. Okay, and this says whose entries, whose row and column numbers are the same. They are going to be 1s. So the identity matrix you'll see is called I sub n. That's the identity matrix. It's an n by n matrix, and we're using the same variable because it is going to be a square. And your diagonal for each of these is going to be 1. Everything else is going to be 0. And then on the next slide, we're going to see what these are. All right, you guys ready for the next one? All right. So here are some identity matrices. So this would be for a 2 by 2. This is for 3 by 3. This is a 4 by 4. Identity matrices, like I said, are squares. I highlighted the 1 so that you could see those. Okay, and then keep in mind that this is going to work commutatively. Now remember, multiplication is not commutative. But whether you take the matrix and you multiply that by the identity, you're going to get that matrix back. Or if you did the identity first and multiplied that by the matrix, you're going to get that matrix back. Okay, so let's look at an example. If you look at the next slide, it says example 1. They actually did everything out for you. We're just going to verify that. So if you were to multiply, the first one you can see, this is your identity. So this is the identity matrix for a 2 by 2, so it's I2. This is some matrix A. And then see how this matrix matches this one? That's showing you that the identity times A is going to be A. But let's go ahead and verify that. Do you guys remember how to multiply from last week? So you have the first row times the first column. So for this one, if I'm finding C11, right, I'm going to do 1 times 3, which is 3, plus 0 times negative 1, which is 0. So 3 plus 0 is going to be 3. Now if I do the next column, 1 times 5 is going to be 5, and then again that would be 0. So then I would get 5. And then that pattern is going to continue. Yeah, Logan?
I guess I'm kind of confused of what, is there something behind when you do that? It's just the same
So yeah, this is just showing you that when you do multiply a matrix by its identity, you are going to get the same thing. So no, you're gonna use this not to multiply them, but we're actually going to find identity matrices. So this is just defining it. So like for this one, this is a different matrix. So this is the matrix B. When you multiply that by the identity matrix, which is a 3 by 3, you are going to get B.
Yeah. It's like,
Yep, it's just like the multiplicative inverse. So what this is showing you is if you multiply a matrix by the identity, you're going to get the same matrix. Just like if you multiply any number by 1, you're going to get that number. So Logan, it's more of a concept than a this is what you're doing. Yeah,
I thought that was like an example problem. I was like, wait a second, that's. I got you. Okay, if I translate this, so you gotta put.
Okay, you guys ready for the next one? Okay, so this is just verifying that when you multiply a matrix by the identity, you are going to get the same matrix. So the inverse of a matrix is going to have this notation. Okay, so if you have a matrix A, we're going to say that the inverse is A inverse, so A with the superscript of -1. So when you multiply a matrix by its inverse, you're going to get the same exact thing if you multiply the inverse by the matrix. And what you're going to get is the identity matrix when you multiply those together. Okay, so for example 2, it says verify that B is the inverse of A, where, and then I'm going to give you your A and your B. So your A is going to be 3, 2, 4, 3. And B is going to be 3, -4, -2, 3. Okay, and yeah, Jonathan, you're going to ask me something.
Does that mean that only square matrices can have inverse? Because if we can multiply both ways, that makes sense.
No, because you can still, like if it was a 2 by 2, you can multiply it by a 2 by 3, because the 2's would line up.
A 2 by 3 is a 2 by 2.
That, right, yes.
So they both have, so they must be square.
So the ones that we're going to do, yeah, are going to have the squares. Yeah. George?
Wait, would it be, for the B, would it be 3, -4, -2, 3?
It's like this for B. So these are given to you.
Okay.
Okay.
I was just wondering, I thought that -4 would be with -2.
So, okay, if you're going to verify, so when you're verifying, you are going to show that A times B is going to be the same matrix as B times A, and that's going to be the identity matrix. And in this case, because they're 2 by 2s, it's going to be the identity matrix for a 2 by 2, which really means it's going to be the matrix 1, 0, 0, 1. Okay, so when you are verifying, the act of verifying is going going to be showing your work that you're multiplying them out. Okay, so first we'll do A times B. Okay, so I have 3, 4, 2, 3 times 3, negative 4, negative 2, 3. And that's a 2 by 2 and a 2 by 2, so my result is going to be a 2 by 2. So I'm going to go here and then here. So the first element in the first row is going to occur by doing 3 times 3, which is 9, plus 2 times negative 4, which is negative 8, and that's how we're going to get the first entry. Is that starting to come back, how we multiplied? So then the first row, the second column, is going to be 3 times negative 2, which is negative 6. 2 times 3 is 6, so that's going to be 0. Okay, and then I want you to do the 2, 1 and the 2, 2. And then once you finish that, you're going to multiply B times A. Okay, and I'm going to give you a little bit of time so that you can do that. Okay, so let's see how we did. Did you guys already verify for both of them? Okay, so when you guys did the second row, the second column, here you get 12 and then minus 12, so you'd have 0. And then for the next one, you'd have negative 8 plus 9, which would produce 1. Okay, and then for B times A, again, you're going to do 3 times 3, which is 9, minus 8, which is going to be 1. For the first row, the second column, 3 times 2 is 6, minus 6, which will be 0. And then negative 4 times 3 is negative 12, plus 12 will be 0. And then for the second one, you have negative 8 plus 9, which is going to be 1. So because both of those equal the identity matrix, you can say yes, that A times B equals B times A. And so that verifies that B and A inverses. Okay, so when you're verifying, this is really your work here. Okay, you're showing that A times B is the same thing as B times A, and you do get the identity matrix each time. Alright, and then let's go to the next one. So the next thing we're going to talk about is finding the inverse of a 2 by 2 matrix. So if you're finding the inverse of a 2 by 2 matrix, there is a convenient formula. So to find the inverse, you can do 1 over A times D minus BC. And then the matrix would be D, the opposite of C, the opposite of B, and A. And this is, A is defined up here. But in case you didn't see that, that's when your A matrix is A, B, C, D. And then you would distribute here. Now you do have to be careful because since this is in the denominator, if AD minus BC equals 0, then A has no inverse. Okay, and that's because you can't divide by 0. This is only going to work if it's a 2 by 2. Yeah, Tim. That. Well, for the inverse of a matrix, if you know what it is, the inverse, and when you multiply, you can get the identity. We're actually going to multiply by the identity so that we can find that inverse. Okay, and then for example 3, I'm going to give you A, and you're going to find the inverse of A. So 6, 4, 4, 3. So this is going to be your value for A. And then we have to find A inverse. Okay, so let's use the rule that we just wrote down for the 2 by 2 matrix. So remember that A, matrix A, is A, B, C, D. Okay, so what's our A value? 6. Our B value? Sydney, what's our B value? Okay, good. Abby, what's our C value? 4. And Lydia, what's our D value? 3. Okay, so now we can use our formula. So the inverse is going to be 1 over, and it says A times D. So this will be 6 times 3 minus B times C. So 4 times 4. Okay, so then Bruno, using the formula, can you tell me what is going to go here in this first position? Okay, and because that's your D value, right? Okay, and then Jesse, what's going to go right here? Yep, -4. Okay, and then Logan B, can you tell me what's going to go here? Yep. And then Olivia, what's going to go here?
6.
Yes. Okay, so now let's go ahead and simplify. So 6 times 3 is 18. 4 times 4 is 16, so this will be 1 over 2. So because this is a scalar multiple, we can just go ahead and distribute. When you are multiplying and it's not a whole number, we're going to leave it as a fraction. So 1/2 times 3 is going to be 3/2, or 3 over 2. 1/2 times -4 is -2. And 1/2 times 6 is going to be 3. So this is our A inverse. 3 over 2, -2, -2, 3. Now, what we just found, part of it does have a special name. The quantity that is the denominator, AD minus BC, that is called the determinant of the matrix. If the determinant is 0, then the matrix does not have an inverse because we can't divide by 0. Let's go to the next one. So what we're going to do is find the matrix of an n by n matrix. For the 2 by 2, we have a formula. Okay? For the other ones, it does not always happen so nicely. So the next few slides are going to explain this. What I say is you're going to create a mega matrix, okay, with the identity and the original. So the book will show you like this dashed line, but we are going to ignore it in the next one. But you'll have all of your elements on one side. You'll have the identity matrix on the other side. So basically, your goal create a mega matrix with the identity and the original. Okay, so you're going to create a mega matrix with the identity and the original, and then we're going to talk about what your goal is. So this is where you start. You're going to start with the identity matrix, and we'll say, and then I'll say matrix A here. So you're going to start here, matrix A identity matrix, and then your goal is to get the identity matrix on the other side so that you can see the inverse. And I just put dashes here because that could really be anything. Okay, so your goal is to get so that you have the identity matrix on one side, because then the inverse matrix is on the other side. So if we're just thinking like of random numbers, I'll just put some random numbers up here. Okay, let's just say we have this matrix, which is a 3 by 3. Then we would add to it the identity matrix. And then we would use our elementary row operations, and through those operations, we would eventually get to the following. Okay, where you have 1, 0, 0, 0, 1, 0, 0, 0, 1, and then you'd have any numbers here. So 5, 10, 15, 20, 25, 30. Okay, so because this is the identity matrix, this is going to be your inverse.
So is there one thing that all n by n matrices where n is greater than 2 have inverse?
If it is the square one, like we were talking about. Okay, so for example 4, you're going to let A be the matrix. This is the 3 by 3 matrix. 3, negative 8, 1. And then 1, negative 1, 0. And then 2, 1, 1. Okay, so do you guys think that you remember what your first step is going to be? What's the first thing I said to do? Yeah, make the mega matrix. So what else do I have to put with the matrix? Okay, so yeah, you have to put in the inverse. Okay, so if you need some help, you can just watch me. Okay, so we're going to begin with a 3 by 6 matrix whose left half is A and whose right half is the identity. So our matrix was 3, negative 8, 1, 1, negative 1, 0, 2, 1, 1, and then we're going to put the identity matrix right next to it. So 1, 0, 0, 0, 1, 0, 0, 0, 1. And like in the book, you'll see like they put a little dash line at first, but that's going to go away. You have to treat this as one whole row here. And because we need some more space, we're going to start this on the next page. Okay, so the first thing I'm going to do is just go ahead and I'm going to rewrite that matrix. So I'm going to have 3, 1, 2, and then negative 8, negative 1, 1, and then 1, 0, 1, and then 1, 0, 0, 0, 1, 0, 0, 0. Okay, so the first thing that I want to do, I want to eventually get the identity matrix here. So I put the goal up on the board, right? What should this first row be? 1, 0, 0, right? So this should be a 1. That's what I should do first. Now there's many different ways I can do that. Does anything stick out to you? Something we could do real quick? Yeah, let's just swap the first 2 rows, right? Now that's not the only way that you could get there. You wouldn't have to do it like that. But we're just going to go ahead and we're going to switch row 1 and row 2. So that means row 1 is now 1, negative 1, 0, 0, 1, 0. Row 2 is now 3, negative 8, 1, 1, 0, 0. And do try to line them up or else it can get a little bit confusing for you. Okay, and we are doing this without a calculator. Okay, so now I have a 1 here. Now I want to get the zeros. Do you guys remember how we did that last week? Added to the of, because what row am I going to multiply by? Think about what's going to cancel out. What's going to cancel out with 3? Negative 3, right? So what row can I multiply by negative 3? The first one. So I'm going to do negative 3 times row 1 I'm going to add that to row 2, and that's going to be what row? Row 2, because we're trying to get row 2 to be 0. At the same time, can I also multiply this by the opposite of 2? So this is going to be negative 2 times row 1 plus row 3, and that's going to be my new row 3. Okay, and then that means row 1 is going to stay the same. Okay, so why don't you go ahead and start trying to do that operation. Okay, so if you need a little reminder, all we're going to do here is negative 3 plus 3, which is going to be 0. For this one, this will be positive 3 plus negative 8, which is what? What'd you guys get? Hello? Did you guys do this part or no? Okay, so negative 3 times negative 1 is what? 3. 3 plus negative 8 is? Negative 5. Okay, this is nice because look, it's 0. So 0 plus 1 is going to be 1. 0 plus 1 is going to be 1. Negative 3 times 1 is negative 3. Negative 3 plus 0 is negative 3. And then this will be 0 plus 0, so that will be 0. Okay, should we do the next one together? So negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Okay, now for the rest of them, just make sure you are paying attention. So negative 2 times negative 1 is what? 2. 2 plus 1 is 3. For our next row, it's times 0. So whenever it's times 0, you're just adding it to the last one. So it'll be 1. Again, it's times 0. So 0 plus 0 will be 0. Negative 2 times 1 is negative 2. Negative 2 plus 0 is negative 2. And then for the last one, it's 0. So 0 plus 1 is going to be 1. Okay, now after you get 1, 0, 0, what's the next thing that you want to get? You want 0, 1, 0. Which one do you get first? There's always one you should get first. You should always get the leading 1 first. Okay, so this is going to be your leading 1. So what could I multiply that by? Yeah, I can multiply by negative 1/5. So negative 1/5 times row 2. Okay, and you are going to have fractions. I decided to do a more challenging one for your notes. Okay, so if I multiply it by negative 1/5, this is still going to be 0. This is going to be 1. Negative 1/5 times 1 is just negative 1/5. So this one will also be negative 1/5. So negative 1/5 times negative 3 is what? 3/5. Good. And then times 0 is going to be 0. Okay, so now that I have the 1, now I can get the zeros above and below. So a good strategy would be to multiply this by the opposite, and then I can add them together. See how these are already the opposites? So what can I just do to those two rows? I can just add them together. Okay, so I can do row 1 plus row 2, and that's going to be my new row 2. Or sorry, that's going to be my new what? Row 1. That's what I want to change, is row 1. You could make it your new row 2, but then that would undo what you've already done. I could also multiply row 2 by what? Negative 3, and then I could add that to row 3, and then that would be my new row 3. Okay, which means our row 2 is staying the same, so I'm going to write that down first. Actually going to give myself more room for this. Okay, so I want you to give it a try, especially the first one, because you're just adding this to it. Okay, so when you added row 1 and row 2, you should have got 1, 0, negative 1/5, negative 1/5. Now when you add this 1 and 3/5, remember you're going to leave it as a fraction. So 1 plus 3/5 is going to be what? 8/5. Good, because you're just adding 5 to the top, and then 0. Okay, now for the last row, you're doing negative 3 times row 2. So negative 3 times 0 is just 0. 0 plus 0 is going to be 0. Okay, for the next one, negative 3 plus 3 will be 0. Okay, negative 3 times negative 1/5 is what? What's negative 3 times negative 1/5, everybody? 3/5. So you're going to do 3/5 plus 1, which is going to be what? 8/5. Okay, and then for the next one, negative 3 times negative 1/5 is going to be 3/5. You're adding that to 0 so you can keep it. Okay, and then for the next one, negative 3 times 3/5 is negative what? Negative 9/5. And then it's minus 2. So you can see as I'm doing this, I'm just kind of jotting this down so that I can deal with my fractions. So negative 9/5. If it was 2, that would be 10/5. So it'd be negative 19/5. Okay, and then the last one is going to be negative 3 times 0, so that's going to be 0, plus row 3, which is 1. So that will be the last one. How did you guys do with that? How'd the fractions go? Okay, then let's talk about what our next step is. So, Colin, what do I want to do next? What's my next goal? Okay, so I have, let's look at what I have. So I have 1, 0, 0, 0, 1, 0. I want to make this row so that it's what? Yeah, 0, 0, 1. And which one of those should I do first? What should we always do first, the 1 or the 0? The 1s. You want to get the leading 1 together first. So what could I multiply by 8/5 that's going to give me 1? Yeah, what's the reciprocal? Right? So I could just multiply row 3 by 5/8, which means my first and second row are going to stay the same. So 1, 0, negative 1/5, negative 1/5, 8/5, 0. 0, 1, negative 1/5. Okay, and then this is great because when you multiply it by 0, those are going to stay the same. This is going to be 1, and now I'm just going to multiply top by top, bottom by bottom. So 3 times 5 is 15. 5 times 8 is 40. And then let's reduce. So what goes into both 15 and 40? 5. So this would be 3 over 8. And then we're going to multiply the next one. Well, really, what's going to happen when you multiply negative 19 over 5 times 5 over 8? The 5s are going to cancel, right? So I'd have negative 19 over 8. And times 1 would be 5/8. Okay, so then the last thing, sorry, I'll circle that. So if you're looking back, you'll know, oh, that's what I wanted to change. So now the last thing that we want to do is we want to make both of those so that they're what? That they're zeros. And we can do them both at the same time. And remember, if you get your 1 first, you can just multiply this row by the opposite. So the opposite of negative 1/5 is positive 1/5. So I'll do 1/5 times row 3. I'll add that to row 1, and that'll be my new row 1. And then I'll actually do the same thing for the next one. I'll do 1/5 times row 3, but then I'll add it to row 2, and that'll be my new row 2. And once we do that, then we should be good. So we have 0, 0, 1, 3/8, negative 19 over 8, and 5/8. Okay, so I'm going to give you a couple minutes to get started on that. Okay, so let's look and see how we did. So 1/5 times row 3. So 1/5 times 0, that's good. So 0 plus 1 is going to be 1. 0 plus 0 is going to be 0. And then the last one is times 1, and then we're going to get our 0. Okay, so the first 3 aren't too bad. Now for the next one, we're going to do 1/5 times 3/8. And if you need to write it out, please feel free to do that. So 1/5 times 3/8, which is going to be 3 over 40. And then you're going to add that to the first row, which was negative 1/5. So minus 1/5. So we have to get a common denominator. So 3 minus 8 is going to be negative 5. What's negative 5 over 40 reduced to? Negative 1/8. So that should be your next one here. Okay, and then for the next one, it's 1/5 times negative 19 over 8. To do this, what I would do, it's just negative 19 over 40. And then minus 1, I'm adding to row 1, so that would be plus 8/5. So times 8 times 8, so it's negative 19 plus 64, which is going to be what? Where did you get for that? 45. And then when you reduce, what goes into both? 5, so it'd be 9 over 8. And then the last one is going to be 1/5 times 5/8, which is nice because what happens there? Those cancel, and then when you add to 0, you're just going to get 1 over 8. Okay, so I'm going to give you some time to do the second row too. Once you get this full matrix, okay, you're going to have the identity matrix, and this is going to be your inverse. Okay, so your inverse, we already know what part of it is. Negative 1/8, 9/8, 1/8 on the top. And then we have 3/8 on the bottom, negative 19/8 and 5/8. So what we have to do is just figure out this middle row here. Okay, so again, the first two are going to be pretty nice because you're multiplying by 0 and then adding 0. You're multiplying by 0 and then adding 1. You're multiplying by 1/5 and adding negative 1/5 to get 0. And then you can multiply 1/5 by row 3. So 1/5 times 3/8 is going to be 3 over 40. And then you're adding that to row 2. So it's 3 over 40 minus 1/5. We actually already did that exact same one in the one before. So that's going to be negative 1/8. 1/5 times 3 over 8 is going to be 3 over 40. Oh, sorry, that's the one we just did. 1/5 times negative 19 over 8 is negative 19 over 40. And then we're going to add that to 3/5. So negative 19 plus 24 is going to be what? 5, and then 5 over 40 is going to reduce to positive 1 over 8. And then the last one, we're going to do 1/5 times 5/8, which is just going to be 1/8. And 1/8 plus 0 is going to be 1/8. Okay, so then your answer here is going to be F, so that's only going to work if it's a 2x2. So if it is a 2x2 matrix, you do want to use that. Okay, so for tonight, if you guys want to start